So here's another example. Okay, now I do have an odd power. One of the exponents is odd, so I'm in the easy case, but it's not 1. Okay, the game now is to use this trig identity to get rid of the largest even power that you can from this odd power here. So use sine squared of x is 1 minus the cosine squared of x to eliminate a lot of powers from that odd power. Watch what happens. So this is not really a substitution or anything. This is just a trig identity. This sine cubed is sine squared times the sine, and sine squared is 1 minus the cosine squared of x, and then I have the remaining sine of x, and then I have cosine squared of x dx. So let me rewrite that a little bit to see how this works out. This is the integral of cosine squared of x minus, and then there's the product of these two, that's cosine to the fourth of x, times the sine of x dx. So now I'm really exactly in the situation that I was in over here. I've got a single power of a sine or cosine. It happens that it's a sine here, but that's not going to cause any trouble. We can go ahead and play the same game that I did there. So far I've just been using trig identities, but now I'll use a trig substitution. And I think I want to write these as powers of a variable, and then this is going to be the differential of that variable. So I'll take u to be cosine of x, and that means that du is minus the sine of x dx. There's the substitution. And so when I make that substitution, what do we get? Cosine squared becomes u squared. Cosine to the fourth becomes u to the fourth. And sine of x dx becomes not quite du. Watch for the signum. Watch for this minus sign here. It becomes minus du. But that's okay. The minus sign comes outside, and I can integrate both of these powers. So I get minus u cubed over 3. And then this fourth power gives me a fifth power when I integrate. And don't forget the constant. Am I done? Not quite done. I have to back substitute and get rid of my choice of variable u and replace it with yours. Questions? There should indeed. I forgot this minus sign when I came down here, so these two gang up to give me a plus. Is that what the other question was about too? Thanks. So let's back substitute, and I'm going to put that over here. And the result is, well, I just replaced the u by cosine of x. So this is minus cosine cubed of x over 3 plus, thank you, cosine to the fifth of x over 5 plus a constant. And there's the answer. By the way, you can remember one of the nice things about doing an integral is it's fairly easy to check your answer. You can always differentiate the thing you get and see whether you get the right thing when you go back. It's not too hard to use the power rules and the differentiation rule for the cosine to get back to this if you want to check the work.